the function is continuous or not. Okay. It's a lot easier to show not than show is. To show is, I've got to work through a three-part definition. Agreed?
Agreed.
So the first thing I need to look at is the limit as x approaches 3 from the left of 3x minus 3. Why would I pick 3x minus 3 if I'm coming from the left?
That's from the left.
That's from the left, right? And that's 6. Does everyone agree?
Agreed.
The limit as x approaches 3 from the right would involve this. Not equal, not continuous. Do I need to go on any more? Why not? Right, because the limit as x approaches 3 of f of x does not exist, right? And if any of the three parts don't work, then I'm done. If this had shown that they were equal, then I would have to go on and say f of 3 is 6. And then I would need to go on and say the limit as x approaches 3 of f of x equals 6, which equals f of 3. But this is enough to show that it's not continuous. As long as one part doesn't work, I'm done. And this is just an old question. Could have been a pre-cal question. Write a function that has a horizontal asymptote at y equals 6, an infinite discontinuity at x equals -4. What is an infinite discontinuity? A vertical asymptote. So this is another word for vertical asymptote. And a removable, what's another word for a removable? Okay, so a removable discontinuity at 5. Well, I'm going to start with those two things. I need an x plus 4 on the bottom, and I need an x minus 5 on the bottom. Everyone agree? I also need an x minus 5 on the top. So I have gotten the vertical asymptote and the whole. How do I get the y equals 6? Why 6x? Good, I need the same degree to make it have a number answer, and so he threw an x. That's the easiest way to do that. You could throw an x plus 2 if you wanted to, but the easiest way to put an x up there is just to put an x and a 6 to make the horizontal asymptote y equals 6. Very good. Okay, today we're going to learn two theorems. They aren't going to come up a whole lot in this chapter. You may see 1 or 2 questions about them on the test, but they will come up a lot as we go on in calculus.
Oh, last one there was another asymptote.
Oh, was there? What I miss? Oh, got that.
Oh, okay, yeah, I'm skipping.
Okay. Okay, I'm recording, people. All right, so we're going to learn 2 theorems that are, as I tell them to you, you're going to be like, duh. They're very obvious theorems. They're ones you could probably figure out. But they actually have huge implications later in calculus, and we're going to use them quite a bit. But we need to know them, and the reason we haven't learned them until now is because we just learned continuity, and both definitions say if the function is continuous. So we have to have understood continuity before we could really understand these 2 theorems, although you probably could have logicked through them before today. So write these 2 down. They will be ones you'll be expected to memorize, but I hope you notice they're not too terrible. You don't have to memorize them word for word. You have to memorize them in concept. So first I'm going to let you write, and then we'll talk and think. I've got about 10 minutes probably of new material today, and then I'm actually going to start some review problems where we start practicing some review problems. The two theorems are the new material for the day. And you might have learned the intermediate value theorem in Algebra 2. Have y'all seen the intermediate value theorem before? No? Okay, I didn't know if you had or not. Sometimes you learn it in Algebra 2. Don't worry, if you haven't learned it, you're not behind. It's really not bad. You will. We're actually going to put something on it. I'm just going to let you write first so that you can think when I'm talking. Again, today is the last new material. Did you look it up? Good. Ah. You can sit by hand, sure. There's not really a whole lot of options in here. Pretty full class. Because this is a cool place to be. This is tree calc. Yeah. Do what? Yeah. But it's fun, right? Intellectual fun, right? Sometimes. But so does football sometimes.
But football's also fun.
I know, just like calculus, right?
No, it's like basketball. It's all about having fun. Yeah. I love basketball.
No. I do too. I played basketball when I was in high school.
I bet you're a baller. You probably dunked all over me. Yeah. We accepted our free weekends for the year. We got one more chance.
I went Friday. Y'all had some moments that were good.
No, that was awful.
There were moments, but then there were other moments where y'all looked really good.
I'm like, oh, we took the ball good. Wait,
You
what's the ball Friday?
didn't notice
Right.
literally everybody left.
That was good.
Oh, I definitely noticed. I was like, very
Gosh, thanks for
They were pretty good, you know. So is everyone finished with the first one? Can I move it down? I went on Saturday. I went and watched my brother-in-law play, and he's 11. On Saturday, I went to a tournament, 11-year-old basketball tournament. I know, but they played a team that had a kid on it that could grab rim.
Really?
And at 11, his team's a 4th and 5th grade team. Some of them were 5th and 6th grade teams.
How big was it? 10 foot?
It was a PE gym, normal goals.
Oh
Yeah.
my gosh.
Yeah, because they're 11 and I'm 5.
I can touch the
Anyway, so that game looked much worse than yours. If it makes you feel any better. And he was a really kind 11-year-old. Like, he passed the ball a lot, and they still won this.
Most people start kindergarten at 5.
My mom went up to Coach Bill at one of our games and said, "Why is my son starting?" That's what she asked him. I heard her. You think that doesn't show some self-esteem? Your own mom took your coach there.
That way you quit it?
That's pretty hot, girl. I don't feel like we're having gender segregation.
I feel like something's still.
Okay, let's get started. I think y'all had time to write. If you didn't, it's your fault. Okay, so if f of x is continuous on a closed interval a to b, so we have a point A and a point B on the x-axis, and we have a function that is continuous from a to b. So if I have a point down here and a point up here, if it is truly continuous, then to get there, something like that.
Don't
right?
stop.
I don't pick up my pencil, right? It says if L is a number between f of A and f of B. Well, f of A is this y value down here, right?
Right.
And f of B is this one up here. And it says L is in between that. So say L is here. I'm making that up. Then there is at least one number C on AB, so in between A and B, such that f of C is L. In other words, I hit every point in between here, right?
Yep.
Duh, right?
Oh, wait.
Is she saying that there's a line and there's a point everywhere?
If L is between f of A and f of B, then at some point between A and B, I'm going to have to hit that L.
I get it. It's just, how are you going to ask a question?
Not yet, but that's just what the intermediate value theorem says. Now, to help you remember the intermediate value theorem, anytime you have a real world scenario, it helps it stick in your brain. So we're going to use 6th grade to 7th grade boys as our scenario. Sometimes 6th grade boys go home over the summer and they're like 4 foot tall, and then they come back and they're like 5 foot tall. From 5th to 6th grade, or 6th to 7th grade, or whenever that happens for you. You may still be waiting on that to happen. It'll happen eventually, right? But that, you know what I'm talking about? You know how that happens to boys?
Absolutely.
Well, at some time over the summer, were they 5'5"? If they were from 4 or 5?
Yeah.
Yeah, if they went from 4 to 5 at some point over the summer, you might not have seen it happen, but at some point over the summer, they were 4'5", right? That's what the intermediate value theorem says. Okay? Growth is continuous. Do what? They needed it for something, and that's where it came from. It came out of necessity, probably. Second, very obvious theorem. Now, quick question. If this is not continuous, does this work?
No.
No. Maybe you had bars put in your legs over the summer. That doesn't count, right? You might, I don't know.
Yeah, maybe you got hit by a car and broke your legs.
And then well, but anyway. But somehow, if we're continuous, we've got to hit every point in between. So is it important for it to be continuous? Yes, otherwise that theorem is worthless. Okay, second one. We again have f of x being continuous on a closed interval a to b. So I'm going to draw a to b. Continuous. It doesn't have to be... I'm going to draw this one different just for fun.
Oh, I don't like that.
Yo.
Could I put an asymptote in there?
Yes. Yes.
No.
No. No.
Why not?
You can put. You can go through
Right? It's continuous, right? It's got to get there. Now, there's a lot of different ways it can get there, but it's got to get there without picking up your pencil. Okay. So if f of x is continuous on a closed interval AB, then there are two values c and d on AB such that f of c is the maximum value of f of x and f of d is the minimum value. So there is a maximum and a minimum. Now it doesn't tell me where they are. They could be at an endpoint. They could be somewhere in the middle. But would you agree there is a definite maximum and a definite minimum on that closed interval?
Yes.
Now, let's talk about what if we didn't have a closed interval. Does that have a maximum?
Yes. No.
No.
No, because I never get there.
That's minimum.
Right, it has a minimum but not a max. So you see why it's a closed interval, open interval wouldn't work. Because I never get there, right? So say this is 3. I get to 2.9 and then 2.99999 and 2.99999, but I never get to 3, so I don't have a maximum value. Does that make sense?
2.9.
Which is 3. If you don't believe me,
I believe you.
0.8 repeating
No,
is,
no.
yeah, no, but 0.8 repeating is 8 nights. 0.9 repeating, wouldn't that be 9 nights? Which is 1.
You got you. Yeah.
0.8 repeating is 8 nights. 0.1 repeating is 1 night. You add those together, you should get 9 nights. So 0.9 repeating equals 1. Do what?
I thought that was pretty cool. Yeah, I never heard that.
Things you learn when you hang out with math teachers. Random thoughts. Okay, so the extreme value theorem says if you have a continuous function on a closed interval, then you have a maximum value and you have a minimum value. So just a random question on intermediate value theorem. If f of x is continuous from -10 to 10, and f of 3 is 7, and f of -2 is -8, does f of x have a 0 from -10 to 10? There is this one yucky word that you will grow to have a love-hate relationship with. Yeah, probably more hate than love, really. It's probably a lot of hate probably gonna come from that word, but we'll sugarcoat it for now and pretend we're gonna like it. Okay, justify means I need to mathematically correctly explain why this is true. So I'm gonna need a theorem, right? First of all, let's just decide if in fact it is true. F of 3 is 7. F of -2 is -8. So way down here. If this is truly continuous from -10 to 10,
The IVT.
what's the only way that I can get from down here to up here? Gotta cross the x-axis. Duh, right?
Yeah.
But justification is a little tougher than that, so I'm going to need to justify.
IVT.
I'm going to use the intermediate value theorem. So yes is the answer. Don't forget to always answer the question, even when it's a justify. Answer the question. Yes, there is a 0 from -10 to 10. Pretty much, to justify using a theorem, I'm going to restate the theorem except with my numbers plugged in. So I'm going to say f is continuous. And you could say from -10 to 10, or you could say from -2 to 3. It's up to you. Either way you said that, it would be fine. It's continuous from -2 to 3. 0 is between f of -2 and f of 3. Why would I say 0 is between that?
Because it's asking for the zeros.
It's the truth. And that's what I need for the intermediate value theorem, right? I need the L to be between f of b and f of a. You could use less than equal to symbols if you want, or you can say the word between. It doesn't make any difference. Everyone agree with that? Therefore, y'all know the 3 dot therefore? Seen that before?
Never seen it.
Never seen it before? That stands for therefore. Math people are lazy. We make symbols for everything. I'm about to teach you more symbols. Therefore.
Use that in our English.
You'd use it in English?
I'm saying I wish I could.
Oh yeah, you can use it in math. Y'all didn't learn that in geometry. Therefore, y'all didn't. Did y'all do proofs in geometry? But anyway,
He didn't teach us.
you think you got it?
Yeah. Bye.
Yeah. She tell you.
Do what? If you'll wait for a few minutes, you can, or you can come back later today. Either way.
Welcome back.
Therefore, there exists. Y'all might want to write that down. This stands for there exists. Sorry. When you go into your first college math class, they will just start writing these and will assume that you know what they mean. You will appreciate that I taught them to you.
What does it mean?
There exists.
There exists.
There exists.
Some do like that.
Therefore, there exists. In fact, if you read a college math textbook, the textbooks use these.
How are you supposed to figure these out if you don't already know?
You're supposed to know them. It is like a different language. Foreign language calculus class. Almost. They kind of expect you to know coming in. Don't worry, you will know because I will teach you. That's my job. That's my job as your advanced math teacher in high school.
Can't wait to get to that lesson.
I'm teaching you right now.
Oh, it's not a lesson.
No, it's just, well, I'll just introduce them as they come up.
Oh, I think we should do a lesson. vocab test.
Therefore, there exists a number C.
Is that the other one?
No, just a number C in the interval -2 to 3, such that sometimes they'll use ST. I'm easing you in.
Every word has.
I'm easing you in. We'll get there. Such that f of c is 0. We'll do more symbols on another 2 for 1 day is good enough. 2 symbols in a day is good. Therefore, and there exists. Okay, would you agree I just stated what the intermediate value theorem says? By the intermediate value theorem. So how do I know? What's my justification? The intermediate value theorem. So let's read this together. Okay. Yes, f is continuous on the interval -2 to 3. 0 is between f of -2 and f of 3. Therefore, there exists a c in the interval -2 to 3 such that f of c is 0 by the intermediate value theorem. Okay, any questions?
Mike got all of that.
I think it did. No one's absent, so no one's going to be watching the video.
Hold on.
Okay. One more example. Prove that the function intersects the x-axis on the interval 0 to 2. Okay, really quick, I want to tell you something about your calculator that you might find interesting. Have y'all ever found a 0 in your calculator?
Yes.
You know how you have to do a left bound and a right bound?
Yeah.
You're having your calculator do the intermediate value theorem. You're giving it a number below the x-axis and above the x-axis, and it just, calculators are stupid, they're just really fast. It just checks until it gets close enough to where it has a 0. Positive, negative, positive, negative, positive, and it's like, oh, there's a 0. Somewhere in between there, because of the
Intermediate value.
Okay, so to prove, much like justify, that function intersects the x-axis on the interval 0 to 2, what's the first thing I'm going to need to say?
It's continuous.
That it's continuous. Okay, why does it have to be continuous?
Because it has to intercept the x-axis.
Not the intermediate value theorem means nothing, right? Often, nah, we don't need a graph. Is it continuous?
Yes.
How do you know? It's a parabola. Is that enough for us to know it's continuous?
Yeah.
We don't even have to prove that. AP is okay with you knowing that a parabola is continuous. I'm going to need f of 0, right? What is f of 0?
2. 2.
What is f of 2?
4 minus 8 plus 2.
Which is?
Negative 2.
Is this tomorrow?
It is.
Oh, eat my dust.
Okay, 2 and negative 2. Does everyone agree?
Yes.
What does that mean?
It means that they're not.
It means that it passes through it.
Good. 0 is between.
2 and negative 2. Or negative 2 and 2.
Good. I'm going to say f of 0 and f of 2. Right?
Right? Did you just plug in the 2 because that's what you got for f of 0?
Because that's the interval they gave me.
You just plug it
I did. And I saw that one was negative and one was positive. So therefore, 0 has to be between them, right? By the intermediate value theorem, there is a number c between 0 and 2 such that f of c is 0. Okay, that's how the intermediate value theorem works. In your homework, it has a couple of intermediate value and extreme value theorem questions on it. A lot of your homework is more continuity stuff because there's not really enough on intermediate value theorem to make up a whole new homework. You know what I mean by that? Tomorrow we'll do a couple of limit review questions in class, and we will have some work time. So you can see we'll do a few little limit questions. Okay? Your homework on intermediate value theorem is due tomorrow. Your other homework is due on Wednesday.